Hello my dear friends, students, and learners. This is Sir Palmat and welcome to my video channel. This is the first part of our topic which we are talking about the general permutation of objects. Specifically, we are evaluating the general permutations. So let us begin with our learning objectives for today's topic. So first, you will be going to illustrate the permutation of objects using general permutations. The next one is, you will be able to derive the formula for finding the number of permutations of n objects taken R at a time. And you will be going to evaluate involving general permutations. So these are the only 3 learning objectives need to learn today's topic. So, are you ready to study and learn more about some of the illustrative examples related to general permutations? So let us start. So today we are talking about the permutation of n objects taken R objects, and it is also known as the general permutation. So we define that the permutation of n objects taken R at a time, so we are referring to the general permutation. So meaning to say, the permutation of whole objects taken at selected number of objects, so at the same time. So is denoted by P open parenthesis n comma R close parenthesis, read as the permutation of n taken R. So in this notation, we have P and R, read as the permutation of n taken R. So the number of permutation of n objects taken R at a time is given by the formula. So we have the permutation of n taken R is equal to the numerator n factorial all over the quantity of n minus R factorial, where n is greater than or equal to R. Okay, so that is the formula for finding the permutation of whole set of objects taken at selected number of objects, which is R. Okay, so today you will be able to evaluate the general permutations using the P and R notation. So in order to us to evaluate general permutations, consider the given example to study some of the illustrative examples and how we'll be able to simplify the given permutation. So let us consider the given math expression. The permutation of 10 taken 4 at a time. Okay? So how will you evaluate this kind of general permutation? Okay, since again, the value of n which is greater than or equal to R. So we let that the value of value of n is equal to 10. So where 10 is the largest value, and the smallest value will be R. So R is equal to 4. So in short, we will use the formula to evaluate this kind of general permutation. So we have permutation of n taken R at the time, which equal to n factorial all over the factorial of n minus R. Okay? So what we're going to do is to substitute the known values of n and R. So we all know that the first, which is 10, so we substitute the value of n is equal to 10, and also we have 4, which is the value of R, and then we'll be able to simplify the denominator or the inside the parentheses. So we follow the PEMDAS rule. So we have 10 minus 4, so we get 6, and then we'll be going to expand among these two factorials simultaneously. So in order to us to simplify the given mathematical expression with factorials on the numerator and denominator, so consider that the smallest factorial, which is 6 factorial, and then you will be able to expand 10 factorial until it reaches to the smallest factorial value. So we have 10 times 9 times 8 times 7 until reach to 6 factorial. So what's the reason why until the last factor, which is 6 factorial? So it is easier to cancel out the 6 factorial, both the numerator and the denominator. So we cancel out 6 factorial, both of these portions of the fraction. So we have remaining factors, 10 times 9 times 8 times 7, and results to the product of the four numbers, which is 5040. And that is the value of permutation of 10 taken 4 at a time, which is 5040. So it is clear to understand on how we'll be able to solve and simplify permutations using the n and the r values. Okay, so let's move on. In order to us to derive a formula of the general permutation P, okay, permutation of n taken r at the time as an alternative solution. So in this formula, we can derive as the shortest method in order to us to solve for permutational problems. So to derive general permutations, let's consider the given formula as we have already discussed earlier. So the permutation of n taken r is equal to n factorial all over n minus r factorial, and we all know that the value of n must be larger than the value of r or equal to that. Okay, we notice that the formula of n factorial, which is also equal to from the largest value going to 1. We have n multiplied by n minus 1 times n minus 2 times until reaches to 3 times 2 times 1. Same with n minus r factorial. So we have n minus r as the largest value, and the next factor would be subtracted by 1. Also the next factor, which is subtracted by 2, and until reaches to 3 times 2 times 1. Okay? So this is the same manner with the numerator and denominator. Okay, but you'll be able to cancel out this. So in order to us to cancel out, we added, of course, the first three terms or first three factors on the denominator, so which could be expounded from the numerator. So n multiplied by n minus 1 times n minus 2 times until reaches 2. We added, of course, we have n minus r times n minus r minus 1 and n minus r minus 2. But we added, of course, to connect with the previous factor. So n minus r would be on the before, which is n minus r plus 1. Okay? We added the new factor in order to us to connect these factors. And then we proceed to 3 to 1 as well. So all of red ones are cancelled out. Okay? So the remaining black ones are the following. So which is n factorial all over n minus r factorial, which is equal to n times n minus 1 times n minus 2 until reaches to n minus r plus 1. And that is for the formula for permutation, which uses the alternative formula, where the value of r means which are indicated the number of factors in the given permutation. Okay, so now you know, my dear friends, students, and viewers, on how will you be able to derive the formula for NPR, or known as the general permutations. Okay, so today we'll be able to evaluate general permutations using the shortest method, and we can be applied using the alternative formula. Okay, so using an alternative solution. So let's go back to our given example or problem, or example, to simplify the given permutation. It is the same problem. So permutation of 10 taken 4 at a time. Okay, so the first step to do is to identify the values of n and r. So let n be the larger number limit and r will be the smaller number. Okay, so the range of values from 10 to 4, so the larger number is 10, so we let the value of n is equal to 10. And the value of r, the smaller value, which is equal to 4. That is the first step. So identify the values of n and r. The next step to do is to put the number of blank spaces, which is depending the value of r, and equate it into the permutational expression. So meaning to say that when the value of r is indicated, it depends how many blank spaces would be put on the right side of the equation that serve as their factors. Okay, so let me say example. Since the value of r is equal to 4, we need to put 4 blank spaces to be filled in by every factors. So meaning to say that with the value of r is given, then we need to put the number of blank spaces depending the value of r. So we have the following. The permutation of 10 taken 4. So 4 which is indicated by color red, and that is the value of R. And we put 4 blank spaces. So we have 1, 2, 3, and 4. So we put 4 blank spaces. Okay? The next step to do is to fill in the blank spaces that we put previously in step 2. Starting with the larger number, which is the value of n, until reaches the lower possible value of r. So take note, my dear friends, students, and viewers. So let us start with a larger value, which is expandable with a factorial. So let us begin with step 3, that is the permutation of 10 taken 4 at the time. Since the larger value is 10, so let's begin with a first factor, which is 10, until it decreases to the last number. So 10 minus 1 becomes 9, 9 minus 1 equals 8, 8 minus 1 is equal to 7, and 7, that is the fourth or the last entry on the blank space. So we have 10, 9, 8, and 7. And the last step to do is to express it into factor form. So then get the product of these numbers. So the olive green numbers which needed to get the product. So we have permutation of 10 taken 4 at the time is equal to, it becomes 10, 9, 8, 7. And that is 10 times 9 times 8 times 7. So, which we get the product, which is 5,040. So, the permutation of 10 taken 4 is equal to 5,040. Okay, so my dear learners, friends, and of course students, so let us compare on the previous method that we will using the general formula, and it's the alternative formula. So we all know that the value of permutation 10 taken 4 using the general formula is 5,040. And that we will use the alternative formula. So this is the same manner. So we all know that we put that which 4 is the value of r, so depending the number of blank spaces which is equal to 4, and we put the factors starting from 10 until the lowest number we put on the last entry of blank space. So from 10 times 9 times 8 times 7, so we get the same value, which is 5,040. Okay? So the result are the same. So any of these two methods can arrive in the same answer. So let's move on to our next slide. So in order to study and learn more about permutation of n objects taken r at the time objects using the general permutation, so I will give you some of their illustrative examples in order to firm up and to study more all about general permutations. Let us start with our first illustrative example. So how will you evaluate the permutation of 9 taken 3 at the time? So in order to evaluate that kind of permutational expression, here is the solution. So let us follow the first 4 steps. So we need to going to evaluate permutation of 9 taken 3. Okay, so we let the value of n, which is larger value, which is equal to 9, and r, which is equal to 3. And we take note that in order to solve easier, so we need to put 3 blank spaces needed, so which is depending the value of r. So with that, we will use the formula permutation of 9 taken 3 is equal to, we put the 3 blank spaces, so that is the value of r. Okay, the next thing to do is to start with a largest value, the value of n, which is 9, and decreasing by 1 in each of the factors from 9, 8, 7. And then we'll be going to express all the green numbers into factor form. So that is permutation of 9 taken 3 is equal to 9 times 8 times 7. And we get all of this product of 3 numbers, which gives the value, which is 504. So permutation of 9 taken 3 at the time is equal to 504. And that is the final answer. So my dear students, viewers, and learners, so let's move on to our next illustrative example. So how will you evaluate the permutation of 11 taken 5 of the time? So to evaluate the given expression, here is the solution. So what we're going to do is to let the value of n and r first. So we all know that the value of n is larger than r, so the value of n is equal to 11 and r is equal to 5. And we need to put 5 blank spaces on the right side of the equation in order to us to give some value, the factors. So we have the permutation of 11 taken 5. So we put 5 blank spaces. So 1, 2, 3, 4, 5. And of course, we put some of these factors starting from 11 until the decreasing value, which puts on the last entry. So from 11 times 10 times 9 times 8 times 7. So 10, 11, 10, 9, 8, and 7. Okay, next thing to do is all of these green numbers that should be expressed as the factor form. So we have 11 times 10 times 9 times 8 times 7. And we evaluate the 5 numbers which get the product, which is 55,440. And that is our final answer. So that is the value of permutation of 11 taken 5 at the time. Okay, let's move on to more evaluating general permutations. So to firm up with this, on evaluating general permutations, let's mix with fundamental operations. So let's start with illustrative example number 3. So how will you evaluate the permutation of 5 taken 3 at the time plus permutation of 7 taken 2 at the time? So in order to us to evaluate that kind of permutational expression, so here is the solution. To evaluate this, the sum of 2 permutations, so this is the same manner to do. So in every term, we'll determine the value of R and depending the number of blank spaces that we need to put in each term. Since the first permutation is 5 taken 3, we put 3 blanks because the value of R, which is 3. And the next term would be permutation of 7 taken 2 at the time. So we need to put 2 blank spaces on the next term. Okay, so that which is very clear. And then what will you do is to start with a factor. So on the first factor, which is the larger values of n. So the larger value of the first permutation is 5. So 5 times 4 times 3. So we are 3 numbers. And then we add, of course, the next 2 terms that we need to put on the blank spaces. So let's start with a larger value of the second permutation, which is 7. So we have 7 times 6. So we have 5 plus 4, 5 times 4 times 3 plus 7 times 6. Okay, the next step to do is to get the product each term. So 5 times 4, so we get 60 as 20 rather times 3, so we get 60. And 7 times 6. Next step to do is to evaluate or to get the product of 5 times 4 times 3. So 5 times 4 is equal to 20 times 3 is equal to 60. And then we add by 7 times 6, which is equal to 42. And then you'll be able to get the sum of 60 and 42, which is equal to 102. And that is the value of permutation of 5 taken 3 at the time plus permutation of 7 taken 2 at the time. And that is the final answer. So we get the answer, which is 102. Okay? So let's move on to our next illustrative example. So how will you evaluate the permutation of 10 taken 7 at the time all over permutation of 8 taken 4 at the time? So to evaluate this, the quotient of 2 permutations, here is the solution. So to evaluate this kind of rational permutations, so what we're going to do is to evaluate this quotient of 2 permutations, so the permutation of 10 taken 7 and permutation of 8 taken 4. So the first step to do is to expand each of the permutations, both numerator and denominator, by its factors. So the permutation of 10 taken 7, so which is equal to 10 times 9 times 8 times 7 times 6 times 5 times 4. So there are 7 factors. All over 8 times 7 times 6 times 5. So what we're going to do is to cancel out these numbers both on the numerator and the denominator. So which is 8, 7, 6, and 5. So we cancel out 8 times 7 times 6 times 5. So will remain as 10 times 9 and times 4. So 10 times 9 times 4. And then we get the product of these 3 numbers. So we get 10 times 9, which is 90, times 4 is equal to 360. So the value of permutation of 10 taken 7 all over permutation of 8 taken and 4, which is 360. And that is the final answer. So my dear friends, students and viewers, so now you know how we'll be able to evaluate and of course to simplify general permutations given and objects taken are objects. So that's the end of our video. So my dear friends, students and viewers, so thank you for watching. So please like, share, and subscribe here and hit the notification bell here at my YouTube channel, Sir Palmath TV. So thank you very much for listening and of course, see you on next video. So God bless us all.